Good evening. This is Professor Wilcox, and today we are going to cover reconstitution of medications. Okay. For this section, the most important thing is you've got to read everything. This is chapter 14. I would recommend practicing some of these in the textbook. So I'm going to start with just explaining what reconstitution is, and then we're going to go through some problems. While I'm going through the problems, what you may want to do on your end is pause it, try to work it yourself, and then check your answers. Okay. So, um, the thing with medications is medication is usually stored in a powder form. And that's because once you mix it into a liquid, after a certain amount of time, it loses its potency. So the process of adding liquid to that powder is called reconstitution. Okay. Most times you will not have to do this depending on your wherever you're working. So, whenever you're doing reconstitution, make sure you read everything carefully. What you care about is the type of diluent, the amount of diluent, the route of administration. And the most important thing is the drug strength or the final concentration. That means how much medicine is in the liquid. Okay. Let's see if I can make it a little narrower, but it doesn't look like I can. Okay. So moving on, you don't really need to know these words except for diluent. Diluent is very important. So solute is the powder substance. So for example, they talk about tea, but I usually refer to Kool-Aid. So if we're talking about, a little packet of Kool-Aid, the solute is that packet of that powdered substance. Okay. The solvent or diluent is the liquid you're going to add to it. And the solution is that Kool-Aid that you get out of it. So the solute would be the Kool-Aid. The diluent would be the water that you add to the powder. And the solution is what you get out of it. And this could be, once you reconstitute, it could be oral, injectable, or for irrigation. Okay. One thing to remember is that this powder usually often adds a significant amount to that volume. So that powder takes up space. Okay. So if it said add 2.5 milliliters of diluent, and then the total volume after you reconstitute it is 3 milliliters, that means that the powder took up 0.5 milliliters of that space. Okay. So they put in 2.5, but the powder in the vial makes it, when you mix it, come out to 3 milliliters. Same as here. So it says you'll add 0.5 to 2 grams to provide an approximate volume of 1 milliliter. And then there's going to be 2 grams per milliliter. So the usual questions are how many milliliters of diluent will you add? And that's that 0.5, that's your diluent. If you wanted to know what the total volume is of the vial, that's that 1 milliliter total volume. But the most important part is this. This is what we call the dosage strength. Okay. This is the most important part because this will be part of the last step of a dosage problem. So again, dosage strength is how much medicine is in the liquid. Okay. So for these, this is just starting off easy. And again, what you might want to do is pause it. But the two questions are how many milliliters of diluent will you add and what is the dosage strength? So it'll say how much diluent will you add? And that's the 5 milliliters. Then I'll ask what is the concentration or the dosage strength after reconstitution? Again, you might want to pause it to find it. And then that answer is 38 milligrams per ml. Okay. So here's another one. It's just the basic questions right now. So you might want to pause it. And again, these are the two questions. How much diluent will you add and what is the dosage strength? So again, I would pause and find it. Okay, so it says how much diluent will you add? And that's right here. You're going to add 2 milliliters. Okay. And then what is the dosage strength after reconstitution? And that's that 225 milligram per milliliter. Again, it's the medicine in the liquid. This 2.2 milliliters will be the total volume after you mix it. But the reason dosage strength is so important, again, just to write it down here, is when you do a dosage problem, which you will do in a minute, right? The doctor orders something, and then you have what's on hand and the cue. This is 2/3 of the problem. So it'd be whatever the doctor ordered over that 225 per 1 ml. Okay. And we'll do a few of those in a minute. Okay, moving on. And this is going to have the 3 questions. So now we're going to build. So these are the usual 3 questions. 1, how many milliliters will you dilute it with? 2, what is the dosage strength of the solution once you reconstitute it? And 3, how many milliliters will the nurse administer? And this last one is a dosage problem, D over H times Q. So again, I would pause it and look through. Okay. So up at the top, you have what's ordered. So this is what's ordered. First question is how many milliliters of diluent will you add? So it says right here, once reconstituted with that 4 milliliters. So that's 4 milliliters. And then keep reading. It says 4 milliliters of the diluent. The resultant concentration is 125 milligrams per milliliter. So 125 milligram per milliliter. And again, this is the H and the Q for your dosage problem. So for step 3, you'll give him his medicine. So what's ordered was the 200. What's on hand is the 125 per 1 milliliter. Making sure I have the right one. And then my final answer came out to 1.6 milliliters. Okay, I have a couple more. So again, you might want to pause it. Same 3 questions. How many milliliters will you dilute it with? What is the dosage strength? And the last one is how many milliliters will you administer to your patient? So again, we might want to pause. Okay, so when you're reading it, up top is the doctor's order. Sometimes people miss that. How many milliliters of diluent will you add? You're going to add 5 milliliters. Okay. What is the dosage strength after you reconstitute it? And that's right here. There's going to be 38 milligrams per ml. 38 milligrams per ml. Okay. You can't use this because that's not it says vial. Your Q is always milliliter tablet or capsule. And then the last part is your dosage problem. So 100 over 38 per 1 ml. It looks like I've got 2.63, and then it does say round. You would have round anyway because of the syringe, 2.6 milliliters. Okay. This one's just breaking it down. I just want to make sure you're familiar with these terms. So again, you might want to pause it. And in a minute, we'll do a dosage problem. So how much diluent will you add? And this one's a little different. You'll have to find it over here. Again, hopefully you paused it. So you're going to add 5 milliliters. What is the dosage strength? And that's right here. 38 milligrams per milliliter. And this is the H and the Q that you will use on the next slide. And then the total volume. Let's see. Where's the total volume? Okay, this one doesn't have it that I see. I threw that in at the end. Adult dosage, each vial contains, that's medicine, medicine, medicine. And 38. Okay, so this one just doesn't have total volume. To be honest, that's not a usual question. But here is the third question usually. Again, the first question usually is what? How much diluent do you add? What is the dosage strength? And then here is the rest of it. This is that third question on how many milliliters will you administer to your patient. So what's ordered is 125. What's on hand was what we already found, which was right there. 38 milligrams per 1 ml. I got to type this one in. 125 divided by 38. And I got 3.28, which you would then round to the tenths place based on the size of your syringe. 3.3 milliliters. And honestly, it's on the next slide as well. Oh, sorry, right there. Okay. And so right here, we're at this one. And I think the question of D over H times Q is on the next one. So again, you might want to pause. Okay. So how much will you dilute it with? It's right here. You're going to add 1.2 milliliters. And what is the dosage strength? If they give you that per symbol, like they've been like 38 milligrams per milliliter, it's very easy to tell. If they said 50 milligrams per 5 mLs, that's easy to find. This one's a little different. So it says right here, each milliliter, when mixed, contains that medicine equivalent to 40 milligrams. So that's the dosage concentration, because there's going to be 40 milligrams in each milliliter. And then this is the H and the Q that you will use for the next slide. So the next slide is right here. And then to do the D over H times Q, again, we already know it was on the previous slide. So what's ordered is the 30 milligrams. What's on hand? 40 milligrams per 1 ml. And I believe you get 0.75 mLs. Okay, next one. So this one, a lot of students miss. I really would like for you to pause this one and try to work it out. A lot of people miss this number 1, actually. Okay, so here's what the doctor ordered. How many milliliters will you dilute it with? So if you look up here, it says you're going to, and again, students don't read. This is the actual answer because it says a total of 78 milliliters. I get a lot of 1/3. I get a lot of students taking 1/3 of 78. But again, this is where you read it. So it says tap the bottle until all the powder is free. Then you're going to add 1/3 of that water and then shake it to wet it. Then add the remaining water. So when it says how many milliliters will you dilute it with, the total is 78 milliliters. So for number 2, what is the dosage strength? You've got 2 places you could find it. Actually, you can find it up here. It's one of the few labels that do say it at the top. I'll write that. And the other way is it should say it right here. It says each 5 milliliters is equivalent to 125 milligrams. Okay. So even though it'll always say it in here as well. Okay. Oh, I didn't do the dosage problem. Sorry. So what was ordered right here was 500 milligrams. What's on hand is 125 milligrams per 5 mLs. I believe that gives you 10 mLs, but I did give you a trick question because it says how many teaspoons will you administer. So 1 teaspoon is 5 mLs, so you'll give him 2 teaspoons. Okay, I did want to go over a couple of these. These usually don't come up on a quiz, but you should see them on homework. And that's where the final concentration or dosage strength isn't just listed for you. Again, here it says it. Here it says it in there. For some of these, and right here, and we'll get into it in just a second, it does not say. Okay, so just to go over it. So for example, again, if it doesn't state it, so it says if you have 1 gram of powder, and let's say you add 2.5 milliliters to give you or yield 3 milliliters of solution containing 1 gram, that's the information. Again, we spoke about that the powder adds volume, right? So you've got 1 gram of powder and you're going to add 2.5 milliliters to that. But what you're going to get out of it is 3 milliliters. And here it says you've got 3 milliliters that contains 1 gram. So it would be 1 gram is 3 milliliters. Okay. to show you, this is another one. And this doesn't have a label. It just is written like this. I think you have one of these on homework. It says instructions, 5 grams on a vial to reconstitute with 250. Since it doesn't have a vial, this is all the information you need. So it would just be, again, how many milliliters will you administer? D over H times Q. And I believe you get 125 milliliters. I know that sounds high, but usually this might be for a possible IV, especially since you have that normal saline there. This is just showing you that a lot of times you have to pay attention to how it's ordered, okay? Because it could be for IM or IV. So here you've got this medication and it can be prescribed. Here it says if you want to prepare an IV, you'll add 7 milliliters. If you want to prepare it for IM, you're going to add 3 milliliters. Okay. So we're going to use this on the next slide though. So right here it says calculate to administer for an IM injection of 400 milligrams. It doesn't have all the questions, but we can go ahead and go through it. So the first question usually is how many milliliters of diluent will you add? So, and again, you might want to pause. So the diluent is where it says for IM, sorry, IM right here. You're going to add 3 milliliters. 3 milliliters. Question 2 is the dosage strength. Let me close that one out just a little bit. So for dosage strength, again, I just wanted to erase this one line because it's so thick. Let me erase both of them. So here, when you go looking in the problem, usually it'll say, you know, each 3 milliliters will contain so much medicine. And again, you really do need to read it yourself, but this doesn't give you the concentration. This one doesn't either. And but it says right here, each vial contains this much medicine, but it still doesn't have liquid anywhere. So, and again, the whole thing is 750. And notice right here, it says each vial contains this much. And then it says, where is it? Shake until it's dissolved, withdraw completely the resulting solution. So the only thing you know, and again, we're talking about the IM, is that you're adding 3 milliliters to the entire vial, and the entire vial has 750 milligrams. So the dosage strength is 750 milligrams per 3 milliliters. So the dosage strength will be 750 milligrams per 3 mLs. And then to do the dosage problem, what's ordered over what's on hand and the quantity. So 400 milligrams over 750 milligrams per, where is it, per 3 mLs. And I believe your answer is 1.59, which would round to 1.6 milliliters. Okay, I think I only have 1 or 2 more. This one's important, just so you'll know, especially if you're in the future. So this is penicillin. So this container of penicillin, you can create it with a bunch of different strengths. You could have 250,000 units, 500,000 units, or 100, or sorry, 1 million. The key here is this is how much how many milliliters you'll add. Okay. And then this is the concentration or dosage strength you'll get out of it. And the key is right there. Units per milliliter. So if you added 18.2 milliliters, you would get the strength of 250,000 units per milliliter. Units per 1 milliliter, not units per 18.2 milliliters. So let's say, and this is the one it's wanting because it says if you add the 8.2, if you add 8.2 milliliters, that will give you 500,000 units per milliliter. So again, it would be 500,000 units in 1 milliliter, not in the 8.2. That's just how much you're going to add. Okay. And then the dosage problem would be what's ordered is the 350,000 units over 500,000 units per 1 ml. which I have to type in. Let's see. Bye-bye. And I got 0.7 milliliters. Okay, I think I have maybe one more. No, okay, that was it. So hopefully that helps. Again, my biggest advice is to pull out chapter 14 in your book and work on reconstitution. Good luck, everybody.